Happy Thursday, 7th Excel. So I just want to do a quick video today on our part 2 of graphing. So this is just an extension on our systems of linear equations graphing. So on Tuesday, on Tuesday, we talked about what the solution looks like when two lines intersect and how the point is their solution. So now I want to talk about, so we know if the solution to a systems of equations on a graph is the point of intersection, then let's brainstorm and talk about the following possibilities. Would it be possible to have a systems of equations with no solution? Think back to when we were solving equations during the school year, when we had one solution, no solution, many solutions. Think about what it looked like when we had no solution. What would that look like for a graph? One possibility here is we could have, would it be possible? Yes, it would be possible if the lines never intersect. So that would be parallel lines, okay? Let's brainstorm. Would it be possible to have a systems of equations with infinitely many? So remember when we were solving infinitely many, the equations were equal on both sides. So that's going to kind of be a similar point here. Here, it would be possible if the lines shared all of the same points. If it was basically the same line, if it had the same slope and the same y-intercept, those would be infinitely many solutions. So let's take a peek at our three types of solutions. So we talked quite a bit on Tuesday about this type of solution, okay? This is called one solution because there is one point of intersection. So what do you notice about these two lines? What do these two lines have different? They have different slopes. They also do, in this case, have different y-intercepts, okay? But one of the key things when you look at one solution is they will have different slopes. So we know, and we've gotten pretty good from Tuesday's work on a one solution and how to identify where that point of solution is. So the next one, when you have parallel lines, is there ever going to be a solution? Will they ever intersect? No. So this is when we have a no solution. Okay, the lines are parallel to one another, therefore they will never intersect. What do they have the same? They have the same slope. They have the same steepness of their line. They're both rising and running by the same amount. But they do have different y-intercepts. So if you see two equations that have the same slope but different y-intercepts, you immediately know that they will rise and run by the same distance, by the same steepness. Therefore, they will never cross one another. So your answer for that type of system would be a no solution. The last type of solution, believe it or not, there are two lines. One is right on top of another. So this is when we have infinitely many solutions because both of these lines that are one right on top of another, they have the same slope and the same y-intercept. It almost doesn't even look like there are two lines there, okay? So let's do an example of each. I know we've done several examples of the one solution, so I want to do an example, one of each of these. So let's see if you guys can quickly identify. So as you notice, our first equation in example number 1 is written in slope-intercept form. It is already written in y equals mx plus b. So let's grab our slope and our y-intercept to be able to graph that. What is that? Okay, our slope is 2. Our y-intercept is -3. So our line graphed begins at -3 on the y-axis, rise 2, run 1, up 2, over 1, up 2 over 1. Okay, now this equation is not written in slope-intercept form. This is kind of in standard form where your x and your y are on the same side. So we are going to work to get this into slope-intercept form. So what would be the equation written in slope-intercept form? Okay, we should have gotten y equals 2x plus 1 with a slope of 2, a y-intercept of 1. So let's graph that. Let's first take a look. So here's my equation. My slope is 2. My y-intercept is 1. On this equation, my slope was 2 and my y-intercept was -3. So based on what we discussed up here, these both have the same slope but different y-intercepts. So what do you think this graph is going to look like? Do you think it's going to be a one solution, a no solution, or an infinitely many solution? Okay, this is going to be a no solution, as you can see on the graph here, because they both have the same slope. One just begins at -3 on the y-axis, one begins at +1. But their steepness going up and over 2 over 1, their slope being 2 over 1, for the same thing, will never allow them to cross or intersect. So this is a no solution. Okay, let's take a look at example number 2. So the first equation is in our slope-intercept form. So I want you to identify the slope and the y-intercept. Okay, our slope is -1/2. Our y-intercept is +4. So it begins on the y-axis at +4, down 1 over 2, down 1 over 2, or up 1, left 2 for negative. So I want you to rework this equation that is not written in slope-intercept form, and I want you to convert it and simplify. Okay, subtract x on both sides, divide by 2 on all terms here to leave us with a simplified answer of y equals -1/2 x plus 4. So here let's identify our slope and our y-intercept, -1/2 and +4. So take a peek. What do you notice immediately before we even graph the second graph about the slope and the y-intercept? What type of graph do you think, or what type of solution do you think from up above are we going to have? Hopefully you answered infinitely many solutions. Why? Because they both have the same, once simplified into your slope-intercept form, they both have the same slope and the same y-intercept. So I honestly don't even need to regraph this because it's the same exact points, it's the same exact slope and y-intercept. So here I'm going to label this line with this equation, and I'm going to label it with my original second equation because they are both equal to one another. Okay, so this line has these two graphs have infinitely many solutions, meaning I can pick any one of these points on there and it satisfies both of the lines. Okay, so let's take a look over here on this activity on number 3. The directions ask you to complete the table by identifying the graphed line that would have no solution with each of these given equations in the table. Record the letter of the line in the table. So I'm going to start with an easy one here. We'll start with one that is already in slope-intercept form, and then we'll go back and we'll revamp this one into slope-intercept form. So this one, without doing anything quite yet, take a look at its slope and our y-intercept. This is going to be key to be able to identify these things pretty easily and quickly. So our slope and our y-intercept are what on this equation? -1/3 and 7. Okay, so if you were going to have a line with no solution to this, so back to our definition again, no solution will have the same slope but a different y-intercept. So I want to look which one of these lines, line A, B, or C, have the same slope as -1/3. Well, before I do that, an easier way to tackle this might be to write my equation of each of these lines. So line A, my y-intercept here, that's at 5. What would my equation of line A be? My equation of line A is going to be y equals -1/3 x plus 5. My slope goes down 1 over 3. This is a negative slope, so I should have a negative slope here. My y-intercept is at +5. So let's identify this y-intercept. I know the numbers are kind of small here. Is at -3. Okay. The next point that crosses nicely to help us find a slope is right here. Okay. Tell me what the equation of line B would be. This equation would be y equals -2/3 x minus 3. From one point to another, it goes down 2 over 3. Negative slope, matches. My y-intercept is -3. Okay. Line C. Okay. I'm going to pick 2 points that cross perfectly. Let's see if I can. Okay, why don't you guys tell me the equation of line C? Okay, this one, when you first count your rise over run, I got 4 over 2, which simplifies to 2. 2x plus 1. +1 slope, or positive slope, +1 y-intercept. Okay, so now that we have these, this is going to help us answer these questions over here pretty quickly. Going back and looking at, if I want a no solution, so I do not want them to cross. Remember, no solution has the same slope but different y-intercepts. So on equation 2 here, that was already written in y equals mx plus b, our slope is -1/3. So which one of these lines has a slope of -1/3? Line A. Would have a no solution with this equation because they'd have the same slope but different y-intercepts. So what I'm going to have you guys do is this equation up top. Why don't you work and get this equation into slope-intercept form first? Go ahead. Okay, I did a little work and showed my solving piece here. Subtracted 2x from both sides, divided all terms by 3 to give me a simplified slope-intercept form of -2/3 x minus 4. So on this equation, which one of these lines would give this system with this one a no solution? Hopefully you answered line B because they have the same slope but different y-intercepts. Okay, I'm going to have you guys try. Okay, this one is also going to be line B because they have the same slope, but they have different y-intercepts. This y-intercept is 0. This one is -3. Okay, I want you to work and get this equation right here in y equals mx plus b, your slope-intercept form. Okay, So I did my first step by adding 8x on both sides, then divided all terms by 4 to give me a simplified answer of y equals 2x minus 2. So which line would be paired with this equation to give it a no solution system? Hopefully you answered line C, because these have the same slope but different y-intercept. Okay, this second to last one, work to get this into y-intercept form, or into slope-intercept form, excuse me. Okay, on this one I subtracted my x on both sides, divided by 3 on all terms, which gives me a simplified equation of y equals negative 1/3 x plus 2. So which other line here would give me a no solution with this system? Hopefully you answered line A. They have the same slope, both negative 1/3, different y-intercepts. Okay, the last equation here, this is already written on our slope-intercept form, so which equation or which line would match this equation to give you a no solution system? Hopefully you answered line C. They both have the same slope, different y-intercepts. Okay, 3 last questions here and then we're done for today. On number 4, Ava thinks that line A and line B above would have no solution because the lines do not intersect on the graph. Is she correct? Explain your thinking. So let's look at line A and line B on the graph. Do you think that these would have no solution? And her reasoning is because the lines do not intersect on the graph. Okay, so this is why it's super important that I make you guys draw arrows and extend your line as far as you possibly can so that you can see. Just because these two lines do not intersect on the graph, if I continued in this direction for line B, in this direction for line A, do you think that eventually these would cross? If you do, you're absolutely correct. Okay, so you didn't have to watch me write the explanation. Let's go over this together though. So is Ava correct? No, because the lines would have a solution, but it's not visible on the graph. The lines are not parallel because they do not have the same slope. If you extended the lines, they will eventually intersect, as we kind of talked about, as you can visualize that way. Also take a peek. These two lines, line A and B, do not have the same slope. Therefore, they are not perfectly parallel. Okay. Question number 5 asks you to write an equation that would have infinitely many solutions with this equation below. So one quick and easy thing, if we want infinitely many, we want basically the same line. So we want another way to write this. Well, this is written in standard form. What's another way we could write this? We could get this into slope-intercept form. So subtract your 5x on both sides. You're left with 3y equals negative 5x plus 12. Divide all of your terms by 3. And you get a simplified slope-intercept form of y equals negative 5/3 x plus 4. So these two lines would have infinitely many solutions because they are equivalent. They're just written in different forms. So they would have the same slope and the same y-intercept. Okay? So those would be drawn one right on top of another and have infinitely many solutions. All right, last one for today. Colin starts with $8.50 in his bank account, and he saves $15.75 each week. James starts with $7.50 in his bank account and saves $15.75 each week. Will the two boys ever have the same amount in their savings accounts? Explain your reasoning. So Colin starts off, so I'm going to use C for Colin over here. Actually, I'll just write this out. And James. Okay, so Colin starts with 850. So we're going to write this in an equation. Y equals. So he starts with 850 and he saves 1575 each week. So that's your coefficient attached to your variable because he's doing this every week. So 1575 per week. Plus he starts with $8.50 in his bank account. James, he starts with 750. So his starting point is 750. That's your y-intercept in his account. And he saves $15.75 each week as well. $15.75 per week plus the $750 he's already got saved gives him a total. So in this case, guys, our y is our total amount of money. And our x, this is how much he saves per week, each week. So x stands for weeks. So take a peek at our two equations here. Will the two boys ever have the same amount in their savings account? So the answer is no. Because they both save at the same rate. Okay, so this is like a graph of two lines with the same slope, but they have different y-intercepts. So if they have the same slope, they're going to be rising and running over the same steepness. So they will never intersect. So they will never have the same amount in their bank accounts. Okay, so that is part 2 of systems of equations. So just remember, there are 3 types of solutions. One solution, look at what the criteria talks about. No solution, and infinitely many solutions. Okay, you guys are gonna do some practice with this today. Have a great Thursday, have a great weekend. Next week, there are only 3 classes left. You can do this.